Now, welcome back. From the first part of our discussion in section 1, we did look at the empirical formula and the molecular formula calculations, and we said the empirical formula shows the simplest whole number ratio, but the molecular formula actually shows the actual number of atoms which are present in a particular compound. And we did a calculation involving a hydrocarbon, and we found out that the final molecular substance had 6 carbon atoms and 6 hydrogen atoms as a complete molecule. Now I want to look at a clip in this particular section which will be able to give us more insight when it comes to the calculations involving the empirical formula and molecular formula. Let's look at the clip.
To mole conversions made easy, brought to you by Book. In this video, we're going to learn how to do mole conversions for elements, how to calculate the molar mass of a compound, and how to do mole conversions for compounds. But before we jump into all that, you might be wondering, what is a mole? Well, there are lots of different moles in the world, but in chemistry, a mole is simply a large number of things. It's kind of like a dozen, only bigger. 1 dozen is 12 things, 1 mole is 6 times 10 to the 23rd things. That is 600 billion trillion things. Now that's a lot of things. But why is the mole such a big number? Because atoms are so small. Suppose you wanted to know how many hydrogen atoms are in 1 cup of water. If you were able to count all the atoms, you would find that there are about 15 trillion hydrogen atoms in a cup of water. But if we count using moles instead, that works out to be only 25 moles of hydrogen atoms. So we use moles to count atoms, molecules, and other chemicals. It turns out that there's an even better reason why 1 mole equals 6 times 10 to the 23rd things. And that is that 1 gram equals 6 times 10 to the 23rd atomic mass units. Let's see what that means for a particular element. Break out your periodic table and look for lithium. It's the 3rd element. On the bottom of the square, you should see the number 6.94. This is the atomic weight of lithium, but it is also the molar mass of lithium. So 1 lithium atom has an average mass of 6.94 AMU, and 1 mole of lithium atoms has a mass of 6.94 grams. That gives us a convenient way to count atoms by weighing them, and the molar mass is the conversion factor between grams and moles. Let's try a problem. How many moles of lithium are in 25 grams of lithium? This is a 1-step unit conversion problem, and like any unit conversion problem, the first thing you should do is write down the quantity that you know. In this case, 25 grams of lithium. Next, multiply this by conversion factor fraction. Remember that for mole conversions, the molar mass is always a conversion factor. 1 mole of lithium equals 6.94 grams. Because we started with grams, we put 6.94 grams on the bottom of the fraction. Grams on the top and bottom cancel each other out. Next, write 1 mole on the top of the fraction. Because the 1 is on the top of the fraction, this becomes a division problem. In your calculator, type 25 divided by 6.94. The answer is 3.6 moles of lithium. You may have been wondering, what happened to the E in mole? Well, it turns out that the abbreviation of mole is MOL. Isn't it just wonderful how much energy we're all going to save by not writing the E? Okay, time for another sample problem. What is the mass of 11.5 moles of lithium? Before we solve this problem, we realized that mass is measured in grams, so we need to convert from moles to grams. The first thing you should do is write down the quantity you know, 11.5 moles of lithium. Next, multiply this by conversion factor fraction. The molar mass of lithium is still the conversion factor. Because we are starting with moles, 1 mole goes on the bottom and 6.94 grams goes to the top. Moles on the top and bottom cancel each other out. Because 1 is on the bottom of the fraction, in your calculator type 11.5 times 6.94. The answer works out to be 79.8 grams of lithium. That is how to convert between moles and grams for elements, but what about molecules and compounds? Let's start by looking at molecules made from carbon, nitrogen, and oxygen. The molar mass of each element is typically written on the bottom. Now, in order to convert between grams and moles for a molecule, we will need to calculate the molar mass of the molecule by adding up the molar masses of all the atoms in the molecule. Let's try a few examples. Carbon monoxide has 1 carbon and 1 oxygen, so we add 12.01 for carbon and 16 for oxygen to get a molar mass of 28.01 grams per mole. In general, the units of molar mass are grams per mole. However, it is very useful to write the molar mass as an equality. 1 mole of carbon monoxide has a mass of 28.01 grams. That helps us remember that the molar mass is a conversion factor. Let's try another molecule. Nitrogen is a diatomic element composed of N2 molecules. Because there are 2 nitrogen atoms per molecule, we multiply 14.01 by 2, so the molar mass of N2 is 28.02 grams per mole. For carbon dioxide, there is 1 carbon and 2 oxygen atoms. So we add 12.01 for carbon and 16 times 2 for the 2 oxygens, which gives us a molar mass of 44.01 grams per mole. We can do the same thing for ionic compounds, like magnesium nitrate. The molar mass of magnesium is 24.3. Because there are 2 nitrates in the formula, that means we have 2 nitrogen atoms and 6 oxygen atoms. So we add 24.3 plus 14.01 times 2 plus 16 times 6, which works out to be a molar mass of 148.3 grams per mole. Remember that we can write the molar mass as an equality, so for magnesium nitrate, 1 mole equals 148.3 grams. That is our conversion factor between grams and moles. So let's go ahead and use this molar mass to do some mole conversion problems. Let's convert 6.35 grams of magnesium nitrate to moles. We will solve this problem in exactly the same way that we converted grams of lithium to moles of lithium. First, write down the quantity that we know, 6.35 grams of magnesium nitrate. Next, multiply this by a conversion factor fraction. The molar mass of magnesium nitrate is our conversion factor. Because we started with grams, write 148.3 grams on the bottom. Because we are solving for moles, write 1 mole on the top. Grams in the top and bottom cancel out. Because the 1 is on the top, in your calculator type 6.35 divided by 148.3. This works out to be 0.0428 moles of magnesium nitrate. What if we wanted to know the mass of 0.369 moles of magnesium nitrate? First, write down the quantity that we know, 0.369 moles of magnesium nitrate. Next, multiply this by a conversion factor fraction, using the molar mass as the conversion factor. Because we are starting with moles, put 1 mole on the bottom, and because we are solving for mass, put 148.3 grams on the top. Moles on the top and bottom cancel each other out. Because the 1 is on the bottom of the fraction, multiply 0.369 times 148.3, which gives us 54.7 grams of magnesium nitrate. Thanks for watching. If this video helped you at all, please give me a thumbs up. It means a lot to me. Feel free to also share any comments or questions you have below, subscribe to my channel, or check me out at catchbook.com.
Thank you very much. I hope you have also given the teacher a thumbs up for that particular very wonderful calculation. And basically now, the conversions between the mass, molar mass, and the moles, and also the empirical formula, the molecular formula, have completely been covered in the entire lesson that we have had today. Otherwise, I want to thank you very much for your session. Let's meet in the next lesson in our Google Classrooms. Let's interact. And if you have any questions, reach out so we can be able to discuss. Have a good day.